In fact, the driver of car N noticed that he was not caught by car M at point D, so he decided to drive with a constant speed for 5 seconds. Specify the type of motion during these 5 seconds. As long as the speed is constant and he's moving along a rectilinear path, then this is a uniform rectilinear motion. So specify, this means that you have to justify your answer. Why? Because moving at constant speed. Calculate the total distance covered by N during the two phases. So we have to go back to the first phase and check the distance covered by N during the first phase. We can find the distance by making use of the position time equation. So it is during the first phase, the position time equation of N is xn equals minus 0.8 t squared plus 30t. Alright, plus 30t, yes, right. Okay, and the initial position was the origin, so that is plus 0. Anyway, calculate the total distance during the first phase. What was the duration of the first phase? The duration of the first phase was just before N passed or went after D. So we have to find at what time did N reach D. N reached D at t equals 10 seconds. This means that the duration for the first phase is 10 seconds because N started moving at constant speed after he passed, or the driver of car N started moving at constant speed after he reached point D. Okay, so that's why the duration of the first phase is 10 seconds. Then in order to find the distance, here we have as if it's plus x0 plus 0. This is x0. Okay, so subtracting it, having the initial position O and D here. Okay, so this is x0. This is x, let's call it xd, which is the final position of the first phase. هذا الفirst phase. Alright, this is the first phase. Okay, so the duration for the first phase here was 10 seconds. Because we already calculated in the previous part the instant at which N reaches D. First phase, and the duration of the first phase is 10 seconds. Now if I substitute in the position time equation of N, like if I have to say like for t equal 10 seconds, N reaches D, so like xn is xd. For t equal 10 seconds, xn is equal to xd. So now I can substitute it in the position time equation. xd is equal to minus 0.8 into 10 squared plus 30 into 10. Okay, so this is xd. Fine. The distance covered by N as it moves from O to D is actually equal to, I'm gonna call it D1. So it's equal to xd minus x0. The distance between them is the difference in the position. So this is xo and this is xd. Alright? So the distance d1 from this point to this point, this is d1. It is equal to xd minus x0. So this is equal to, we have to find xd then, minus 0.8 times 10 squared is 100, so this is minus 80, plus 300 is equal to 220 meters. Okay, we already calculated it in part 1, but I was just trying to relate things. We already in part 1 proved that xd is 220 meters away from the origin, but I'm just repeating it in a different way from the perspective of N, we can say this. So it is xd is 220 meters minus the position of the origin is 0, so this is 220 meters. Now this is d1 for the first phase. What about the second phase? The second phase, the duration of the second phase is 5 seconds, and the speed is constant, and it started moving from D, so the initial position of the second phase is from D, 5 seconds here. So knowing that it is moving at constant speed, we know that the general position time equation for the second phase x2 is called could be written as vt plus the initial position. Okay, let's not write it 2 now, just okay. So x in general for URM is x equal vt plus x0. Fine. So in order to find the expression, not the general one, the expression for this case, we need the initial position and the speed during this phase. The initial position during the second phase, this is for the second phase. Okay, for the second phase, the initial position is d, as xd. So this is because it started moving from d, 220 meters. And the speed is the speed also at d. So where did we calculate the speed at d for N? Calculate the speed of the car. No, not this one. So we did not calculate it previously. We have to calculate it now. So this V is actually VD. You know that it's VD because it started moving at constant speed starting from D. So I have to go back to the first because the initial position here is actually the final position for the first phase. I have to go back the speed time equation of the first phase for N in order to calculate VD. So we have the general equation V equal minus 1.6 t plus 30. We substitute for t equal a 10 to find VD. So knowing that from the first phase we have that V equal minus 1.6 t plus 30, and D belong to the first phase because it's the last position for the first phase. So VD is equal to minus 1.6 into 10 plus 30. This is equal to minus 16 plus 30, which is equal to 14 meter per second. Now, having VD, I can express the position time equation of the second phase is equal to x into V is 14, t plus x0. We said that it's 220 meters because it's equal to xd. So now for t equal to 5 during this phase, x of n is equal to x final that I labeled here. So xf is equal to 14t plus 220. Instead of t we have to write 5. So xf is equal to 14 into 5 plus 220. So it is equal to 14 times 5 on your calculator, 70 plus 220. This is gonna be equal to 290. Still not done. In order to find D2 covered during the second phase, I have to subtract XF minus XD. So it's equal to XF minus XD, which is 290 minus 220. So it is equal to 70 meters. This is D2. The question is calculate the total distance. So it's not enough to find D2 and D1. So D1 here, distance, it is 70 plus 220, 290 meters. Now finally, draw the speed time curve of car N for the two phases.